Hey guys, here Weird Physics, and today we're going to see a video about distance in acceleration. So I recommend you to see my past video about the basic formula in acceleration and my video about velocity. Thanks for watching and I hope you enjoy. Don't forget to subscribe. So here we come back to our graphs. So you can see here we have velocity and time, and I marked them 1 2 3 4 5 and 1 2 3. So imagine a car starts from 2 meters per second and accelerates and goes to 3 meters per second in 2 seconds. So in 2 seconds. So how can we graph this? So if it starts from 2 meters per second, the velocity will increase. So it goes like this. So from 2 it passes some time, and then we have like a line, keeps going, and finally it ends at 3 meters per second, and it took 2 seconds. So what we want to know is what was the distance the car made when it did that. So if you remember from the velocity video, the area we have here will be the distance the car did. So how can we calculate this distance? Maybe you're ahead of me here. So what we can do is we can separate this like this, and we can calculate the area of this rectangle and then add the area of this triangle, or we can calculate the area of this big rectangle like that and subtract the area of this triangle. And you'll say why can we do the two choices? It's because you're going to need different variables for each of them. So if you have one variable and not the other one, you can use this one. But if you have another variable like the final velocity, then you will use the other one, and you will see in a minute. So we'll try first the plus. So this one plus this one, and it will give us the area. So let's just color that so we can see what's the area. So that's the area. That's not the area. So for the first, distance or the area will be equal to, so what's the area of this rectangle? The area of this rectangle will be the time multiplied by that's the initial velocity, because you know it started at 2. So initial velocity multiplied by the time. So initial velocity, we'll say it's v with an I. So initial velocity multiplied by the time. So here we have initial velocity multiplied by the time. So that plus here, how do we calculate this? So this is a half, because it's a triangle. The formula of a triangle, it's a half times the base multiplied by the altitude. So it will be a half multiplied by the time and multiplied by this is the final velocity. So here we have a half, 1/2 multiplied by this will be the final velocity. So Vf for final velocity. Oh, sorry, so that's final velocity minus the initial velocity, because final velocity it's all this. So final velocity minus the initial velocity, that's that, and we will have this little line here. So final velocity minus initial velocity, and this is this line, so this will multiply it by the time. Good. So but here we have brackets, and we don't want brackets, we want to simplify that. So what we're going to do is, from the formula, acceleration is equal to final velocity minus initial velocity over time that we saw in the last video. We're going to bring this time to this side, so we're going to have acceleration multiplied by time, because it's dividing, so it goes multiplying, equals final velocity minus initial velocity. So here we can see that final velocity minus initial velocity, here, that is the same thing than acceleration multiplied by the time. So we're going to use this, it's much simpler. So we have that distance is equal to initial velocity multiplied by the time plus a half multiplied by AT, and because AT multiplied by T, it's simply AT squared. So AT multiplied by T, AT times T, AT squared. Good, so here's our first big formula of the distance. Now, if we want to take the big one and subtract the triangle, we're going to do, so what's the area of the big one? Final velocity multiplied by the time. So here we have final velocity multiplied by the time minus, that will be final velocity minus initial velocity, oh sorry, so distance is equal to final velocity minus initial velocity multiplied, because we're going to multiply this or this by the time. And as we saw here, final velocity minus initial velocity, it's simply acceleration multiplied by time. So distance is equal to final velocity multiplied by time minus, oh, and that's a half, sorry, minus a half of AT squared. So here we have our formulas, the big formulas, this one and this one. So here, if you have the initial velocity, you'll use this one, but if you have the final velocity, then you'll use this one. So you can practice. I'm going to let you some problems. So here, a car accelerates from 5 meters per second to 10 meters per second in 20 seconds. What distance did it do? And the second problem, a ball falls from a window and hit the ground at 19.6 meters per second. The acceleration of the ball was approximately of 9.8 meters per second square. What was the height of the window? Suppose it was on a vacuum. So vacuum where there's no air, not vacuum like vacuum, no. And the answers to these problems will be on my next video, and I hope you enjoyed, and don't forget to subscribe. Thank you.